My second presentation starts with improving the bus transfers. On-chip bus uses three mechanisms to speed up this transfer. First is transaction splitting, second pipelining, and the third is bus mode operation. So let's start the first two, transaction splitting and pipelining. Transaction splitting. The transfer of an address is a separate transaction from the transfer of data. Each transaction has its own acknowledgement signal. So it separates the address and the data phase. By doing this, a bus slave will need some time after the reception of an address in order to prepare for data transfer. And this will improve the transfer. The second is the pipeline transfer. The pipeline transfer introduces overlap in the execution of bus transfer phases. Since we have address phase and data phase, then this pipeline transfer introduces overlap on these two phases. The timing diagram shown in the slide, an overlapped read-write transfer, that is a write followed by a read. On clock H2, the bus master indicates a write address ADR1. The bus slave acknowledges this address on clock H3. By acknowledging the address, the slave merely indicates it is ready to accept the data. From clock H4, the bus master executes two activities. First, it sends the write data, which is data 1, to the bus slave. Then it initiates the next transfer by driving a new address 2 on the address bus, that means. So at this stage, it's performing two activities. On clock H5, two events takes place. The bus slave accepts data 1 and it also acknowledges the read address 2, that means. Finally, on clock H6, the bus slave returns the data resulting from the read operation, that is data 2. Through multiple control or status signals, the bus master and the bus slave are able to improve the bus transfer in an overlapped fashion. So here, by doing the transaction splitting, that means by having address phase and data phase, and by doing some overlapped activities, we are improving the transfer. And if we improve this transfer, we are improving our system performance. So let's see the last mechanism to improve the transfer, and this is bus mode transfer. It is a mechanism that will transfer multiple data items from closely related addresses in on bus transfer. That is, in one bus transfer, we are able to transfer multiple data, but this data may be located on some closely related addresses. Bus mode transfer can have a fixed or variable length. In a fixed length bus mode scheme, the bus master will negotiate the bus property at the start of the bus transfer and next perform each transfer within the bus. In a variable length scheme, the bus master or the bus slave has the option of terminating the bus after every transfer. So there is an option that to terminate and continue or after some time, which is convenient maybe for the slave or for the master. So there is an option to terminate on the variable length scheme. As it's shown in my slide, it illustrates a bus transfer of 4 increment address words. Here I introduce a new command, signal embraced. It is used to indicate the type of bus transfer performed by the master. So this is used to indicate that the transfer is going to be a burst mode. I am just considering increment of 4, meaning a burst of 4 consecutive transfers with incrementing address. Since it is increment 4, that means it increments the address by 4. On clock H2, the bus master indicates the bus transfer and drives the address and the embrace command, showing that it is increment 4. On clock H3, the slave accepts this transfer, and after that, the master will provide 4 data words in a sequence. The address information provided by the master after the first address is in principle redundant. So in this fashion, we are improving the transfer by making one transfer in a continuous and consecutive many data that is located in relatively close addresses. This concludes with the 3 mechanisms to speed up the transfer.